Welcome back to Physics and Chemistry Made Easy. Today's topic is Basics of Measurement. First of all, what do you mean by measurement? You are comparing an unknown quantity with a known quantity. That is called measurement. What do you mean by this statement? Definition. Suppose say I am having a potato. You don't know the mass of this potato by just holding it in your hand, because there is no sticker as such. There is no sticker over the potato. How to know the mass of this potato? You have to place this potato over the balance, maybe a common balance or spring balance, something like that. So what happens? This unknown is compared with known. That is what you mean by measurement. And measurement involves physical quantities, many physical quantities. Now what do you mean by a physical quantity? A measurable quantity. Physical quantity is a measurable quantity which has two things. One is units and the other one is magnitude. If these two things are present, then it is called a physical quantity. Now physical quantities are divided into how many types? Exactly, physical quantities are further divided into two types. They are Physical quantities are further divided into two types. They are fundamental quantities and derived quantities. Exactly. Physical quantities are further divided into two types. Fundamental quantities and derived quantities. What do you mean by a fundamental quantity? Quantity which does not depend upon others. Independent quantity. Fundamental quantity is an independent quantity, while derived is what? Dependent quantity. Yes, exactly. What do you mean by independent quantity? What do you mean by a dependent quantity? We will come to know now. In altogether, how many physical quantities are there? Excellent question it is. Altogether, how many physical quantities are there? There are many. There are many physical quantities. And further, they are classified into two: fundamental quantities and derived quantities. Then let us ask one more question. How many fundamental quantities are there? How many derived quantities are there? Now comes the question, how many? Therefore, it is so clear that fundamental quantities, which are independent quantities, okay, they are 7 in number. They are pakka 7 in number. Other than these 7, see, one side we pulled out. All the physical quantities are now one side we have pulled and said that fundamental quantities are just 7. That means whatever is remaining, okay, it comes under derived quantity. For example, say there are 50 students in front of me and I pulled out 10 and said that these are the best students. Then it's understood, isn't it? The remaining 40 are not the best ones. Like that, it is total physical quantities are classified into two types: fundamental and derived. This you need not count how many. No need, not necessary. Because among all the physical quantities, 7 are treated as fundamental quantities. Just 7. The remaining are called derived quantities. Then we'll write down what are those 7. First one is length. Second one is mass. Third one is time. Fourth, temperature. Fifth one is current. Sixth one is luminous intensity. And the seventh one is amount of substance. Now coming, these 7 are fundamental. Pakka these 7 are fundamental and only these 7 are fundamental. and they are independent. They don't depend upon others. Just an example, if you ask me what is my height, then I will say I am 5.5. What do you understand by this? In which direction? Is there any possibility to ask like that? Nothing else. Only one question, I did not my height to calculate my length, okay, or height. What I mean is length is height, nothing but. So this quantity did not depend upon others. But now see, very interesting thing about derived quantities. I want to calculate area, density, volume. So when I write these derived quantities, do not get confused. If I come across any quantity, like suppose acceleration I said, now you need to think like this. Is this acceleration present on this side? No. Anything which I write here, if it is not existing here, then it's called a derived quantity. Such an easy thing. Why? Because these are just 7. These are fixed. These are just 7. If I write down here velocity, if I say speed, if I say momentum, impulse, force, etc. Whatever I speak other than these 7, they are called derived quantities. It's like that. So clear, it is so clear. Now coming to the point, what actually you mean by this? So you need not worry about this one. Fundamental are just 7, they remain like that. So area, density, volume, acceleration, velocity, speed, momentum, impulse, force, and many more. Whatever physical quantity you come across, right? They all come under derived quantities. Now let me prove it. What do you mean by dependent quantity? Yes, I will prove it. What do you mean by dependent? I want to calculate velocity. So what is the formula to calculate velocity? It is displacement by time. Now see the interesting thing. Velocity, on the whole velocity, you don't find it here. That means it is a derived quantity. Derived quantity means if you want to calculate velocity, this is the formula, displacement by time. You know, displacement is the shortest length. That means it is this velocity is nothing but length by time. Where do you find length? Yes, where do you find length? It's here. Where do you find this time? It's here. That means you don't have velocity here. But to calculate velocity, this is the formula, length by time, and length by time is available here. That is the reason these are called derived quantity. Derived. You are deriving its value by taking the help of fundamental quantities. So the velocity is depending upon this one. That is why it is called derived quantity. Dear students, please remember one thing. Fundamental quantities are 7. First be clear with that one. Other than that, if a teacher speaks saying that what is volume, simply say it is a derived. So velocity. Velocity is equal to what? Displacement by time. Displacement or distance means its length. Length by time. Where is length now? It's here. Where is time? It is here. That is why it is called derived. In order to find velocity, velocity is depending upon fundamental quantities. So if it want to design its value, it is depending upon. So it is deriving its value from fundamental. That's why they are called derived quantities and dependent quantities. Okay, done. So we finish velocity. Next, let us take speed. Same manner, speed is also same manner. Speed or velocity doesn't make any difference. One is vector, the other one is scalar, that's all. Speed is equal to what? Distance by time. What do you mean by distance? Length. Length by time. Yes, length by time. Why displacement has become, distance has become displacement? Because displacement has the definition saying that displacement is the shortest distance. That means displacement is nothing but distance. Only thing is what? Displacement is a vector quantity while distance is a scalar quantity. Displacement or distance means nothing but length, nothing but length, because the unit for displacement in CGS system is centimeter. Unit for distance in CGS system also centimeter only. Unit for length in CGS system is also centimeter. That means distance or displacement, length, height, width, breadth, all this means nothing but length. So anyhow, that is another category. But see, speed is equal to distance by time. Distance is nothing but length by time. Where do you find this length and time? Here. That is why speed is a derived quantity. You don't find speed here. See, you don't find speed. But you find what? Length and time. Therefore, to design speed, you are depending upon length and time. Where do you find these two? Here. That is why these are branded. These are just 7 in number. Okay. These are other things are called as derived quantities. Next one is area. Now tell me, do you find area here? No. No means it's understood it is derived. Such a easy thing. If you don't find a physical quantity what I am writing here on this side, then it is derived. That's all. You know area is length into breadth. What is actually breadth? Just now I said length, breadth, height, distance, displacement, all this come under length only. So it's length into length. Nothing but length square. Now where is length? It is here. That means to calculate area is depending upon these quantities. That is the reason they are called dependent quantities. Now one more, volume. Right, let me take volume. Formula for volume is what? Length into breadth into height. Nothing but what just now I said, length into breadth is also length into height is also length. How? Suppose say something is long, we say length. Something is short, we say it is breadth. Something has a height, okay, height is having something inside, then we say height. What is this one? Length. Suppose say we are using CGS unit as centimeter. Here also is use the same centimeter, here also we use the same centimeters, whether length or breadth or height or distance, displacement, width, all these come under the same category called length. Right, so therefore it is now length cube. That's all, simple. So all these are depending upon fundamental. Fixman, you remember properly, fundamental quantities are 7. Other than this, whatever you write, it is a derived quantity. Now tell me, derived quantities are how many? You need not give the answer for that, because it has no answer. Because other than fundamental, they are all derived. Okay. Suppose I want to derive now I want to know what is the formula for density. What is the formula for density? Mass by volume. Something more. Now tell me, mass is mass term. Just now I told you, volume means what? Length cube. Mass, where is mass? It's here. Where is length? It's here. Therefore, it is very clearly told that this density is a derived quantity, because you don't find it here. At the same time, in order to calculate density, it is depending upon these two, that is mass and length. And where do you find these two? They are present here. And what are these? Independent. They are not depending upon derived. Derived quantities are depending upon fundamental. That's why these are independent and they are dependent. Like that, you can write down so many other physical quantities. Why am I using the word physical quantity? Because these two categories come under physical quantity only. A measurable quantity which has unit and magnitude. Few more, there are so many like this, okay? Acceleration, the other one you can take acceleration, rate of change of velocity. So it's velocity by time. Rate in the sense it is time. Now what happens in time, right? You keep time aside because it is a denominator, time. Velocity means what? Displacement by time. Now what is displacement? Distance by time square. Why did I write square? Because these two are time and time. Displacement is nothing but distance, but time and time square. Distance is nothing but what again? Length by time square. That means what's happening here? Again, acceleration, if I ask you what is acceleration, you should simply say that it is derived. Why? Because to calculate acceleration, the formula is length by time square. Length, fundamental, time, fundamental. Therefore, this is derived. In order to calculate its value, it is depending upon fundamental and deriving its value. That's why these are called derived, dependent. Like that, there are so many physical quantities I can write. Okay, force, mass into acceleration. Force is mass into acceleration. Then coming to impulse. Impulse is nothing but force into time, right? So if you may be thinking about how to calculate force. F is equal to ma, mass into acceleration. Acceleration, velocity by time. So like that. One thing, dear students, other than these 7, they are called derived, because these quantities depend upon fundamental quantities. Such an easy thing it is actually. Okay, good. Now altogether, physical quantities are also divided into 2 types based on magnitude and direction. That is, if a physical quantity has both, if a physical quantity has both magnitude and direction, then it is called vector quantity. If a physical quantity has only magnitude but no direction, then it is called scalar quantity. Example, speed. It is represented with v. Speed is equal to distance by time. Say I am traveling on two-wheeler with a speed of 70 km per hour. Now what do you understand? It is just speed. Where am I going? Not necessary. I am just speaking about speed. My vehicle is having this speed, that is 70 km per hour. If I say I am traveling with 70 km per hour speed in towards east, since I mentioned the direction, therefore it becomes velocity. Velocity is a vector quantity. Velocity is a vector quantity, means it has magnitude as well as direction. While speed, it has only magnitude but no direction. So based upon this, these physical quantities are classified into 2 types, vector and scalar. Now how to remember this? It is also easy. Tricks, there are some tricky methods. Vector we write like this v. So it involves 2 things, magnitude and direction. Then scalar you need not show it, because it has got only magnitude. Vector, once again, vector has got 2, vector we showed v like this. So it has got 2 things, right? One is magnitude and the other one is direction. Now let's discuss about dimensional formulas. So let me take volume. Volume means what? Just now I told you, length into breadth into height. See, long one we call it as length, a shorter one we call it as breadth, and the one which is having an altitude we call it as height. After all, these are nothing but length into length into length, that means length cube. Now, systems are of 3 types, CGS, NKS and SI. Right? Fundamental quantities are 7. Now, all 7 fundamental quantities will have unit only in SI system. In CGS system, you don't have units for the 4 fundamental quantities. Only for 3 you have units only for 3. That is length, mass and time. These One more. Why these systems are written like this only, like CGS, MKS, why not GCS and MSK? Why? Because these are written according to length, mass and time. Now what do you mean by this? These three are fundamental quantities, length, mass and time. So they are written like this. Unit for length in CGS system, what do you find under L in CGS system? C. Therefore it is centimeter. Unit for length in MKS system, what do you find here? M. So it is meter. Same way this is mass. Unit for mass in CGS system, what is it you find here? G. Gram. Unit for mass in MKS system, what is present here? K. So it is kilogram. Time means it is second. So these are written according to length, mass and time. Now I want to write the unit for volume. So unit for volume, that is CGS and MKS system. As just now I told you, these are written according to length, mass and time. So what is this one now? Length cube. So CGS unit of length is what? Centimeter. Therefore the unit is centimeter cube. If I speak about MK system, my formula remains same. Length cube. Volume means it is length cube. Length into breadth into height. Therefore it is what now? Meter cube. Now if I want to write a dimensional formula for volume. Dimensional formula for volume means what? Actually now I have something like length cube. So MLT. I don't have a mass. As such I don't have anything like gram and kilogram. Therefore mass to the power is 0. I have length. It is length cube. I don't have something related to time over here. Therefore again it is also to the power of 0. Therefore this is the dimensional formula of volume. Actually if you really know the units properly, you don't have a problem with the dimensional formula. Now let me take one more thing, like density. Right? Density is equal to mass by volume. Now as I was telling you, these systems are written according to length, mass and time. These are written according to length, mass and time. Now mass, I got mass. So I need not derive it again. Already it's a fundamental quantity and I got it. I got mass. Therefore it remains like that. Mass. Just now I told you what about volume. Length into breadth into height it is. So nothing but what? Mass remains like that. And it is length cube. Therefore my CGS unit, okay, I'll write down here. CGS unit of mass is what? Gram. And CGS unit of length is what? Centimeter. But since it is volume over here, centimeter cube. So in the same way, MK system, you can see here MK system, mass is kilogram, and this is length cube, length is what? Meter. Therefore it is meter cube. Now dimensional formula for density. What do you have on the top? Mass. Therefore mass 1. Right? Nothing else is there. Okay. And what else you have here down? Length, and it is cube. Therefore it is coming on the top. Therefore it is -3. You don't have anything related to time. Therefore it is 0. M to the power of 1, L to the power of -3 and T to the power of 0. This is the dimensional formula of density. Density, mass by volume, mass by length into breadth into height. Nothing but mass by length cube. That's all it is. So simple. Now next I will write something about little bit more about momentum. Let me write down about momentum. Momentum is a vector quantity. Momentum is represented with P. Vector quantity, you have to draw an arrow on the top and it is mentioned with P. Momentum is what? No, mass into velocity. Momentum is mass into velocity. Now look at the board. Easy to learn, not an issue at all actually. Now coming to mass. Mass is a fundamental quantity. It remains like that. Velocity is not a fundamental quantity. In those 7 fundamental quantities, you don't find velocity. That means it should be derived. That means velocity is equal to what? Displacement by time. Right. So what is left over for you now? Mass is mass, fundamental quantity. Displacement, distance, length, everything means the same. Therefore it is length here. and by time. Now you tell me interesting thing. These are all now in what? These are all fundamental quantities. I need not go further deriving something. It's understood. So these are written according to length, mass, time. I told you these are written according to length, mass and time. Mass. So these are written according to length, mass and time. So mass unit in CGS is what? Mass, gram. Therefore it is gram. Into unit for length in CGS system, what? It is centimeter, and next it is time, therefore it is second. Same manner it is kg, meter per second. Now dimensional formula MLT. Do I have anything related to mass? Yes. So mass is 1. I have something related to length, and that is 1. Time, I have time, right? It is denominator, so it has to come on the top, -1. These are the dimensional formulas for momentum. M to the power of 1, n to the power of 1, t to the power of -1. It is all easy actually. Okay. Velocity or speed both mean same. Velocity is a vector quantity while speed is a scalar quantity. Velocity requires direction, speed does not require direction. The next one is acceleration, very important. Acceleration, you should know the definitions of this. Okay? And acceleration is represented with E, very good. Acceleration is what? Rate of change of velocity. It is rate of change of velocity. What do you mean by rate? Time. So you mean to say it is velocity by time. That's all. Velocity by time. Right? You know velocities are of two types. So it is v minus u by t. This is the formula of acceleration. Acceleration formula it is. A is equal to v minus u by t. Still nothing but what? Accelerate. These two come under only one category. V is called final velocity. U is called initial velocity. If any object starts from rest, then u will be 0. In all the problems of kinematics, if a body is starting from rest, if it is given like a body starting from rest, u is considered 0. If a body stops on application of brake, means v is 0. Final velocity is 0. Final velocity we call it as v, initial we call it as u. For after all, what is this one? Velocity by time. Now you tell me, velocity is a dependent quantity. Velocity into time. So you write this by time aside. Okay, done. I shifted this time aside because velocity means it is again displacement by time. So finally distance, displacement, nothing but what? Length, acceleration. Now it is finally length over here. On the top you don't have anything. You have displacement into time, nothing but distance into time, nothing but length into time is length. By time into time. Denominator you have 2 times, therefore it is time square. Now you tell me CGS unit, I want write here. Okay, let me write here CGS unit and MKS unit. As I told you repeatedly, these are written according to length, mass and time. What do you have here? Length. Length CGS unit is what? Centimeter. And time is what now? Second. Square, because the time square it is. Same manner MKS. What is here? See, I am clearly showing you what is what. This is length, only length, only length. Therefore it is meter. Since it is time square bottom, therefore time square. This can be also written as not only this, other things also you can write. You can write like this, what? Centimeter, second inverse. Or this same way, this you can write it as meter, second inverse. Right, leave it. Now M, L, T, dimensional formulas. What do you have here? What do you have here? Length, on the top, length. Okay, length is one. Do you have anything related to mass? No, mass, you don't have anything related to mass. You have related to time? Yes, something is related to time, but it is denominator, it's coming on the top, therefore -2. So, these are the this is the dimensional formula for acceleration. M to the power of 0, L to the power of 1, T square inverse we call this one, square inverse or -2 also, to the power of -2 you can read out, okay. This is something about acceleration. We can write down these type of dimensional formulas for all the derived quantities and fundamental quantities, not an issue at all, depending upon their formula, right. Now I will teach you other methods involved in measurement. Suppose say you are given value like this. It is 1000 by 100. What will you do? Students find difficult in solving such type of problem actually. So two zeros you are cutting down and you are getting the answer as 10. This is okay. This most of the students simply do this one. Simply. Now the problem is where, suppose same problem it is given like this, 10 to the power of 3 by 10 to the power of 2. Right? Then what? Why you are getting confused? It is similar to this one. Same question it is. Same question but given in a different way. 10 to the power of 3 means what? After 1, 3 zeros. Means it is same 1000. 10 to the power of 2 means what? After 1, 2 zeros. So you can solve it like this. Let 10 to the power of 3 which is on the top remain like that. Since you are bringing this 10 to the power of minus 2 on the top, it becomes 10 to the power of minus 2. You are bringing this 10 to the power of 2 on the top, therefore it becomes negative. Now what is the answer left over here? 10 to the power of 1, nothing but 10. Such an easy thing. Whatever the value is, suppose it is 10 to the power of 4 by 10 to the power of 2. It means what? 4 zeros and here 2 zeros. So 2 zeros when you cut, the answer is 100. Similar way, if directly you are given 10,000 by 100 also, you will get the same answer. This is one type. Now I will tell you the other one. It is very easy. Please note this. The other one I will tell you is very interesting. Given 4.00 into 10 by 2. Now students find this type of problem also very difficult. What is there in this? I don't understand. Such an easy problem. Now after decimal point, how many digits are there? 2. So let us make it 1. Altogether 1. Therefore it's not over. What is your denominator is 2. Since after decimal point you have 2 zeros and you made it into 1, you have to take down 2 zeros down. This remains as it is 10. So it is what now? 200 ones are, 200 twos are, 2 into 10 is equal to 20 is your answer. Suppose say, let us take down the question once again. It is 4.00 by 2 into 10 to the power 10. Now suppose I do it in this manner. 2 ones are, 2 5s are. So what is left over for me now? 4.00 into 5. Now check out your answer. 5 zeros are 0, 5 zeros are 0, 5 fours are, it is 20. So since after 2 digits you have a point over here, so count from this side. After 2 digits point. Your answer is again 20. What is there in this? Either you go for like this. Suppose say you don't have the same number. It is easy number. 2 ones are, 2 5s are. If not like that also, you go on for this type of things. Try to know. If you are removing a point here, how many digits are here? 2 more. So you will be getting zeros here. Same way if it is in a reverse way also, it is same. Suppose say you are having 2 on the top and down you have 4.00 into 10. What you need to do? It is same. Let 2 be here and you are removing this point, therefore after point you have 2 digits. You remove the point, therefore you have to take 2 zeros on the top into 10. Now what happened? 1s are and 2s are. 2 1s are, 2 5s are. So your answer is 5. Now the other way. Suppose it is 2 and 4.00 into 10. What has 4.00 got to do? Nothing. It is 2 by 4 actually into 10. So it is 2 1s are, 2 2s are, 2 1s are, 2 5s are. So your answer is again 5. Either you remove. If it is 0, I am taking easy one. I can understand. I am taking 0 easy ones. After 4 2 zeros, therefore I remove 2 zeros. Okay. If there is a number, then just remove the decimal point and take the same number of zeros on the top. See, I have a number 2.2, right? 20, okay, into 10 to the power of 2. What is the answer for this 2.20 into 10 to the power of 2? My answer is 220. Okay, right. Now Now suppose say I want to shift this next question 2.20 into 10 to the power of 2. This you should understand, 10 to the power of 2 means nothing but 100. Now I want to shift this decimal point, just one number. Now I want to add this decimal point after 2. No? So what am I doing? Come on. It is 222.0. This is what my new question is. Into 10 to the power of 2. So remember, if you are moving towards right, depending upon the number of digits you are putting a point, okay, that many zeros you should take to the power of minus. So what is happening now? Let us see. It is 22.0 into 10 to the power of 2 minus 1 is 1. The answer again remains to be same, 220. Now coming to another question. See, I want to shift this decimal point. So my question, I am writing my question, it's like this. I want to shift this decimal point this side. That means let me make it first 22.0. Sorry. It is 0.22. Yes, I am shifting the point this side, isn't it? So 0.22 into 10 to the power of 2. This is my question. I shifted towards which side now? Left side. When you shift towards left side, you add the number of zeros. When you shift towards right side, you remove the same number of zeros. How many you have shifted, that many number of zeros to be removed. If you are shifting towards left, then go for addition. That means what shall I do? It is my 0.22 is into 10 to the power of 2 is my question. I shifted towards left side. How many digits did I shift? Only 1. Therefore, I need to take 10 to the power of 1. So on the whole, what is it? 0.22 into 10 to the power of 3. Nothing but 10 to the power of 3 means into 1000. My answer remains same. 220. Why particularly I took 220? Why this? I want to show you that if you shift towards right side, one digit or 2 digits, depending upon that, you will get values in negative zeros. Suppose you are shifting towards right, whatever the number is, if you are shifting 1 or 2, depending upon that, you will get values of 10 to the power of this one value. It will be plus.